Hi all, welcome to the NPTEL online certification program, and the program which we are dealing with is a biophotonics. So I will be your online TA for the program. Introduce myself. I'm Jijit. I'm an interdisciplinary research scholar of IIT Madras, and I'm working in the field of interdisciplinary of chemistry and biotechnology, where my primary research focus is protein degradation using single molecule for spectroscopy, mainly optical laser. So in this biophotonics course, actually for the online TA program, we will be discussing some model questions, and we will discuss some basic concept, and we'll check how this the terracotta lectures are useful for the program. Okay, today today is actually the additional session. Here also we will mainly deal with our module 11 or the week 11 course things. So we'll discuss the some basic concept of the things of the lectures, and we'll also discuss some model assignment problems. So hopefully you are enjoying the course. I believe like that way. So today we will deal or we will discuss some of the problems. Today is actually the additional 1 hour class we will take. So if you have any doubt and other things, you can discuss now, as well as if you have any doubt in the course and other thing, please give through our course feedback such that we'll go through the course now. Actually, we'll go through the questions, and along with the questions, we will deal or we will teach the basic concepts. Okay. Just go through the questions. Hopefully, I'm going to share my screen. Hopefully, the screen is visible to you. So, first question is actually the question regarding the clean room. So, the question is that if there are more than 237 particles of 2 micrometer size per cubic meter of the clean room, then which class of the clean room does it belongs to? So, this is actually a discussion which we are dealing with the first video. The lectures regarding the first video is actually telling about this clean room facilities. So we can see that there are different class of the clean rooms. So based on this ISO certification, so international standards organization classifications, we have different clean room facilities like class 1, class 2, class 3, class 4, class 5, class 6, class 7, class 8, and these are like as we are increasing the number, actually this is the cleanliness. Actually, you can see cleanliness is actually decreasing. So we already deal with this one. If you have any doubt, just go through the lecture number 1. So in class 1 clean room, actually it contain only particles of the size zero point 0.1 micrometer and zero point 0.2 micrometer. So if the class 1 clean room containing zero point 0.2 1 micrometer and zero point 0.2 micrometer, zero point 0.1 micrometer should be in 10. So just we can have some. So, so this is a class 1 clean room. If class 1 clean room, it can have 10 number of zero point 0.1 micrometer and 2.2 micrometer maximum. This is the maximum can have. So whatever the class clean room which is defined is much more not in this standard. In class 2 clean room, we can have zero point 0.1, 100, 0.2, 24, 0.3, 10, 0.5, 4. So this is not also like that. So class 3 point 1 can be 1000, point 2 can be 237, point 3, 1 or 2, point 5, 35, and 1 micrometer, 8. So you can see that a clean room which is having a particle saying zero point 0.2, 237 is actually class 3. So the answer is actually class 3. ISO class 3 can contain at max. So this is actually the thing. So we can say. So this is actually the limit of the class 3 bond. Okay. Again, doubt, just ask. So let's go to the second question. In an MBE chamber, the mean path of the atoms is of the order of. You may have gone through the lecture which containing this MBE. What is MBE? MBE is a molecular beam epitaxy. How it is working? So in that thing, there will be different chambers containing the particular molecules to be coated with a shutter. And this thing will be in the ultra pure condition with the high pressure in this chamber, and it is actually open towards a vacuum chamber. The ultra high vacuum is also there, and the substrate is kept here. And using the specific method, what it is doing, you can open this shutter and make a small hole such that this high pressure thing will be ejected in a very fast, and it will reach on the particular substrate. So MB, this is using very small hole through which that molecules are actually ejecting, and the condition in the ultra pure vacuum actually enables to get a very high mean free path. What is actually mean free path? Mean free path is the, if you're considering a gas molecules and other things, or some flowing molecules and other things, mean free path is the path between two collisions. So we are expecting that the collision, as the molecules move together, there is a chance that these molecules will collide each other. So while these molecules are moving together, so the path in between two collision, actually this molecule will move in a straight line. So the average distance between two collisions is actually called as a mean free path. So if the intensity of the molecule or the concentration of the molecule is so less, and if there is nothing to collide, and the purity of that thing is very high, what happens, the mean free path is actually increases, because you can get molecule by molecules. Actually you are ejecting molecule by molecules, that means the mean free path can be very high. So the normal molecular beam epitaxy have a mean free path of 50 into, oh, sorry, 5 into 10 raised to 6 centimeter. So this will be equal to 5 into 10 raised to 6 into 10 raised to minus 2 meter. So 5 into 10 raised to 4 meter, or 50 into 10 raised to 3 meter. So the mean free path, since this is a choosing very small opening such that molecule by molecules are ejecting, and it is passes through a high vacuum condition and reaching to the substrate, so it can have a very high mean free path. So the order of the mean free path is around 50 kilometer. So the answer is 50 nanometer around 50 micrometer around 50 centimeter around 50 kilometer. So your answer is 50 kilometer. Okay. If you haven't doubted, just just go through that one and just see whether any problems are there. Going to the third question. Which of the following is a process that involved in nanofabrication? So, as we are going through this thing, crystal growth is actually a thing in nanofabrication. Lithography is the making different patterns on the substrate is called lithography. Ion implantation is also a part in the nanofabrication techniques. But the smelting is actually coming inside our metallurgy process. So the problem answer for this problem is not involved in nanofabrication is melting. So the answer is C. Okay. Going to the next question. Oh, sorry, I forgot that answer also I put it here. So, statement one. When negative photoresist is used, everything except the exposed region can be removed. Statement 2. When a negative photoresist is exposed to UV rays, polymer chain undergo cross-linking and hence cannot be removed easily. When negative photoresist is used, everything except the exposed region can be removed. When negative photoresist is exposed to UV rays, polymer chains undergo cross-linking and hence cannot be removed easily. So, how the photoresist is working? So, when we are putting a mask and there will be a photoresist polymer will be there. So, if it's a positive photoresist, what happens when we are exposed to UV? There, the molecular interaction between the polymeric or the monomeric chains are actually decreasing. So, what happens when you are using a developer or an etching material? Actually, you can wash away all the things where it is undergone the photoresist where it is exposed. But what happens in the case of a negative photoresist material? When a negative photoresist material is using, what happens when we are exposing the exposed polymer with the UV light? So extra cross-linking is happening between the monomeric molecules such that that becomes some hardens and when we are using some developer materials, all the photoresist material is removed except the place where this exposure, UV exposure happened. So the answer is C. Both statement 1 is actually correct. Statement 2 is also correct. Statement 2 is actually a explanation of the statement 1. So, C. Which of the following methods of thin film deposition yields thin films of highest purity? So the self-assembly techniques. Self-assembly techniques, we are saying that there will be some liquid or a thing where we use keep our substrate and the liquid is actually or solvent or the liquid is actually getting evaporated and that material to be coated is actually getting coated on the substrate by itself. And there is a molecular beam epitaxy which we already discussed here. There will be some different chambers containing high purity molecules in the vapor form and there is a small opening through controlled by some shutter and using that opening of the shutter this high pure molecules like yeah with this small hole actually high pure molecules is actually shoot to the substrate and it is coated on the substrate. In chemical vapor deposition what happens it uses a chemical interaction between different this gaseous species and the interaction between that gaseous species on the reaction chamber is actually causes the substrate to be deposited is getting deposited on the substrate. So that so the method which is actually giving the highest purity thin films is actually molecular beam epitaxy. So the correct answer is B. these techniques. Going to the sixth question. In the molecular beam epitaxy, dashes are used to control the flow of atoms onto the substrate. So actually, we already gone through the molecular beam epitaxy techniques. So there are like a very high pressure molecules in the vapor state, which is enclosed in the chamber with the small openings, which is closed using different shutters. That thing which actually closes the chamber are called shutters. And while opening the shutter, actually this high pressure, the molecules at the high pressure is actually targeted towards the substrate in the molecule by molecule level at a high speed and actually getting deposited on the substrate. So the mechanism which uses to open and close such that molecules can be released in molecular beam epitaxy is called shutters. So The answer is actually C. Shutters. Which of the following nano devices can be utilized to simultaneously study thousands of DNA or RNA species? It's called. So we already see there are like different methods which we can actually study different DNA or RNA species together. So that will containing some arrays that corresponding to different probe. That probe can be also DNA. So some another DNA can become as a substance. So if that DNA, particular DNA can form a complementary strand with this rope thing, so there will be some mechanism such that it can be getting detected by using fluorescence or other means. So so that DNA which we require, or the properties of the DNA which we are giving as the substrate can be understood. And this method is actually known as DNA microarrays. Okay, the method is called DNA microarrays. So the answer for that question is option B, which is DNA microarrays. Going to the next question. The correct order of steps involved in the pattern transferring process in nanofabrication is. So let's see how the nanofabrication process happens. The typical nanofabrication process happens. So there will be a substrate. On the substrate, what we will do, we got some photosensitive material using some spin coating or some method. Then above that one we put a photoresistive material. We put so there is a mask or something. Then we use some UV rays to expose this mask. It will be some positive photoresistive material or something. Then it happens that this portion is actually getting weakened. So when we are developing, what happens? Or there can be some layer of oxide can also be here. Depends on the process. The oxide layer. And we use the develop. And some etching process will happen since that this portion is getting etched. So like that way we can actually do the nano fabrication. So let us go to the material. Substrate electron beam exposure metal deposition resist spinning. So this is not that correct. First metal deposition not happening. On the substrate actually resist spinning is happening. Electron beam exposure, then development, metal deposition, then lift off. So this is the correct answer. So the option is C. If you have any doubt, just go through the basic procedure of this nanofabrication method, and you will be clarified with this. Going to the next question. Which of the following thin film deposition techniques can be carried out under both atmospheric as well as under low pressure conditions? Molecular beam XP we can do only at low pressure condition. So that much high purity is required. So we cannot do it under atmospheric condition. We cannot at all. We can do. We cannot do. Self-assembly techniques. Self-assembly techniques actually what happening is that solvent is actually getting this removed, and that we cannot even do at low pressure conditions. So if you had a solvent at under very low pressure, that everything get evaporated instantly. So that we cannot do that. So there is another thing, chemical vapor deposition. Chemical vapor, what happens? The vapors of the chemical is actually getting reacted and got deposited on the thing. So it depends on the conditions of the reaction. That thing can happen at low pressure as well as atmospheric pressure conditions. So the answer for this question is actually B. The chemical vapor deposition techniques can be used to do the atmospheric as well as low pressure conditions. Okay. Having doubt, just ask. In chemical vapor depositions, what is happening? There will be a chamber on which the substrate is actually kept. The purity of the chemical vapor deposition techniques will be less compared to, and different channels will be there for different substrates. So different substrates are there. So this the channel for another substrate. So the vapor actually comes here and getting reacted and it got deposited on the substrate on the chamber. So these are the one method which can be used to do a graphene coatings and other things. So it depends on the reaction, like methane, hydrogen, these different components we can be used it for this graphene coatings. And the thing, since this is not a very high pure and other things, so depends on the application of the system, we have to decide what kind of deposition method we are supposed to use. So if you want like a ultra pure uniform coatings and other things, molecular beam epitaxy will be very useful, but the expense for that equipment will be very high. And we our technique is something which is actually like graphene coatings and other things, we can use the chemical vapor deposition. And there are like self-assembly techniques which can be used at a very low cost effective manner and other things. So it depends on our requirement, depends on the application. Actually we can decide what kind of techniques we can use for our coating the particular molecule on the substrate. Okay. So different methods, chemical vapor deposition and self-assembly and molecular beam epitaxy, which you can use for different nanofabrication. So going to the next question. In which of the following nanomaterial quantum confinement occurs in one dimension? The quantum confinement occurs in one dimension. It's happening in quantum. Well, okay. One dimension quantum confinement happening quantum well. So today we go through the different nanotechnology based things, nanofabrications and different methods used in nanofabrications like molecular beam epitaxy, chemical vapor deposition, and what is called self-assembly method, and how these things are working, and some ideas about this clean room systems, then electron beam molecular beam epitaxy techniques, and different nanofabrication techniques, and different principles involved in nanofabrication techniques, and other things. And if you have any doubt, just go through this thing, and please let me know any doubt. Please. So hopefully this class is useful for you, and if you have any doubt, please free to ask any doubts in the our Google group thing, and we will go through your doubts and try to clarify these doubts. And if you have any clarification regarding any questions or assignment questions or any classroom concept or other things, everything you can clear the, and will prepare for the exams, and do your assignments in an interesting manner. And I am wishing you all the best for your assignments as well as the exam. Okay, we'll meet in the next online session. Thank you. I'm closing the session such that